Welcome to section 5.2. We're going to talk about factoring and a specific type of factoring. We're factoring out the greatest common factor. Remember, GCF is greatest common factor. And we talked about how to find those in the last section. Today, we're going to factor polynomials by taking out or factoring out the greatest common factor. We use that word factor a lot in math. To factor something means to write it as a product. Like, for instance, if I told you I wanted you to take the number 6 and write it as a product of primes, I would have 6 equals 2 times 3. What we have done is we have written the prime factorization of 6. So we see that word factor all the time in math. The prime factorization of 6 is 2 times 3, and we've been doing prime factorizations. So to factor really means to write something as a product. To write as a product, as a multiplication. Okay, and our job in Unit 5 is to learn to factor polynomials. So we're going to write polynomials as a product of simpler polynomials. Just like when we take 6 and we write it as 2 times 3, we're writing 6 as a product of things that are more basic. The prime numbers are more basic than what we call composites. So 6 can be written as a product of the primes 2 and 3. 6 can also be written as 1 times 6. That's another factorization. But 1 is kind of boring, so we usually want to factor things so that they're a product of simpler pieces, like primes. So when we factor, what does it mean to factor? To factor means to write as a product. Multiplication. Product means multiply. So today we're going to do GCF factoring. So to factor out a GCF, the first thing you have to do is you have to find the GCF. So you look at all the terms of the polynomial, however many terms you have, and you find the GCF for all of the terms. So find the GCF, or greatest common factor, for the terms, all the terms. If the leading coefficient is negative, we'd like to have polynomials in standard form when we're factoring. If the leading coefficient is negative, you're going to want to make your GCF a negative and factor out a negative with that GCF. Third thing, figure out what the GCF needs to be multiplied by to get back to the original term. Fourth thing, write your answer as a product. So there's that word product again, so we're multiplying. Write your answer as a product of the GCF and a simpler polynomial. If the GCF is a 1, the polynomial is considered to be prime, and we won't write it as a product of simpler things because it really can't be done. Okay? So, for example 1, we're going to factor this polynomial. Notice this is a trinomial. It has 3 terms, 1, 2, 3 terms. So there are 3 terms, and we're going to factor out the GCF. So the first thing you have to do is look at the 3 terms. Here they are, 6x to the 5th, 8x to the 3rd, and 4x squared. And your first job is to find the GCF. Well, we look at the 6, the 8, and the 4, the coefficients, the 6, the 8, and the 4, and all of those are divisible by 2. But we don't have more than a 2 because 6 is not divisible by 4, right? So the GCF is going to have a coefficient of 2, but notice we have an x squared and x to the 3rd and x to the 5th. So our GCF is actually going to be 2x squared. That's from our last lesson, right? So GCF is 2x squared. So what we're going to do is we're going to rewrite our original polynomial. Here's the original. We're going to take this original polynomial. We're going to write it as 2x squared times a simpler polynomial, or a polynomial of degree smaller than what we started with. So what we need to understand is that when we factor out the GCF, we are undoing distributing. So when we distribute, we multiply each term by the thing that we're distributing. So when we're factoring out the GCF, we're dividing the GCF out of each term. So what we will look at is right here. So we figured out that the GCF is 2x squared. So I need to figure out what multiplies with 2x squared to create 6x to the fifth. Well, I can just divide. And what that leaves me is 3x to the third. 6 divided by 2 is 3, and x to the fifth divided by x squared is x to the third. So we just reduce that fraction. For the next one, I need to take the 8x cubed. Notice the minus sign that carried across there. Okay. We're just undoing distributing. So on this one, we're going to take 8x to the third, and we're going to divide by 2x squared. So what piece do I have to multiply by to get my 8x to the third back? 8 divided by 2 is 4, and x to the third divided by x squared is x. So we have a 4x. That's where this came from. And then finally, the last one, the last term is the 4x squared right there. So we need to do the 4x squared divided by the 2x squared. And what's that going to create? Well, 4 divided by 2 is 2, and x squared divided by x squared. The x's are gone, so I just have a 2. Okay? So what I have done is I've rewritten each of the three terms that we started with. 6x to the fifth, there it is. The 8x to the third, there it is. And lastly, the 4x squared. We've written them as GCF times whatever remains. Okay, so we've figured out, so that was step 3, figure out what the GCF needs to be multiplied by to get back to the original term. And we write our answer as a product of the GCF. So here's step 4, product of the GCF and a simpler polynomial. So there's our GCF out front. Maybe I'll write that right here. So this is our GCF. There it is, the 2x squared. And then we have that GCF multiplying with a simpler polynomial. But notice this is still a trinomial. It will still be a trinomial. And also notice you can check your answer by distributing that 2x squared back through. So if we check our answer, it will work. We can check by just distributing. The 2x squared times the 3x to the third creates the 6x to the fifth. See, if we multiply here, that creates the 6x to the fifth. If I multiply here, positive 2 times negative 4 is negative 8, and then x squared times x is x to the third. And finally, the 2x squared times the positive 2 creates the positive 4x squared. So it does check, it works. Okay, so you can check your answers here by redistributing that GCF and making sure it comes back to what we started with. Okay, so let's do some examples, several examples. So we're going to do example 2. We'll start there. So the first thing I'm going to look at is my terms are y squared and 2y. And I need to find the GCF for those. So I'm going to look at the y squared as being y times y. This is 2 times y. What do they have in common? They have a y in common. Look, there it is. They have a y here and a y here. So your GCF is a y. So what we're going to do is we're going to take the GCF, we're going to pull it out in front, and then I'm going to do y squared divided by y. Oh, look at what happens here. If I take out a y, what's left is a second y. And if I take out from my second term right here, if I take out the y, I'm left with a 2, but there's a negative sign in the middle. So we have that. That is our answer. The answer is y times y minus 2. Okay? And you can think of it as dividing out the y if you want to. So we pull our GCF, and we have y squared divided by y minus 2y divided by y. And we get this answer. So there's different ways you can look at it. Okay, example 3. We're going to take our two terms, our 2z to the fifth, oops, not 2, 12, our 12z to the fifth, and our 36z to the second. We're going to find our GCF. So I'm going to look at that 12, and I'm going to break it down. So I'm going to do a prime factorization. That's 2 times 2 times 3. And then z. How many of them? 5, 2, 3, 4, 5. And then the 36. If you need to go to prime factorizations, you can do that. But you know what? Let's look for an easier way. As we do this. So 36, and I'll just take the 36 and break it down. 2 and 18, 2 and 9, 3 and 3. So that 36 is 2 times 2 times 3 times 3. And then the z squared is z times z. Now what do they have in common? Well, look at what they have in common. They have a pair of 2's, both of them. They have a 3. And then they have z squared. So our GCF is 12z squared. So we're going to write down the GCF, which is 12z squared. Okay. And then I'm going to write down, so my original polynomial is going to equal, then I'm going to write down what I have left. Okay. So for the first one, if I take out the 2's, the 3, and 2 of the z, look at what's left. Z to the third. So I divided out a 12 and a z squared. So that leaves a z to the third power plus, notice the sign in the middle is still a plus. And then for the last one, if I take out 2, 2, 3, and z squared, the only thing that remains is the 3. So 36 divided by 12 is 3, and z squared divided by z squared, the z is gone. And there's our answer. Check your answer by distributing, make sure it works, and it does. Okay, example 4. 4x plus x squared. I am tempted to switch that around and put it in standard form. I think I will. I'm going to rewrite it as x squared plus 4x. It wouldn't be wrong not to, but I'm going to get in that habit right now of writing it in standard form. So I'm going to switch the order. And then I'm going to look at the two terms, x squared and 4x. Notice what they have in common. They have an x in common. We've got an x here. We've got an x here. I really don't need to break the 4 down into a 2 times 2 because my x squared, notice it has a coefficient of 1 in front of it. So the coefficient of my GCF is going to be a 1. So my GCF is just going to equal x. So what I will do, once I've found that GCF, that's my first step, right? Find the GCF. Find the greatest common factor for the terms of the polynomial. I don't have to worry about factoring out a leading coefficient. I don't have to worry about factoring out a negative because my leading coefficient is positive 1. Well, okay, let's factor out the GCF. And then what's left? Well, if I take out an x, I'm left with an x. And if I take out an x, I'm left with a 4. Or, as we said, you can do, to figure out what needs to go here, you do x squared divided by x, which is x. And to figure out what goes there, you can do 4x divided by x, and that's 4. Final answer, x times x plus 4. And remember, you can check your answer. All right, we're going to look at example 5. I have this polynomial in example 5. I've got 7x to the 5th as one of my terms. I've got 12y squared for my second term and 19d to the third. I know it's a negative, but don't really need to worry about the negative. 19d to the third. So notice that 7 and 19 are both prime. 7 and 19 are both prime, so the GCF for the coefficients is going to be 1. And do you notice all my variables are different? I have x in the first term, I have y in the second term, and I have d in the third term. So the GCF is just going to be a 1. So this is one of those where if the GCF is a 1, we call it prime. Okay? We'll learn some other factoring techniques later on, but even with the new factoring techniques that we learn later on, that one's still going to be prime. Okay. Example 6. Notice my terms. 4k to the third 8k to the second, and 4k. Do you notice that 8 is divisible by 4? So the GCF is going to have a 4 as the coefficient. And then k to the third, k squared, and k, they all have a k in common. They all have a factor of k. So the GCF is 4k. So once we have found that GCF, we're going to factor it out. So we have 4k times, let's see if I do 4k to the third. A couple ways I can do it. I can write that out as 4k, k, k. If I take out a 4 and a k, I have a k squared. The other way to do it would be to look at the 4k to the third and ask yourself, if I divide out a 4 and a k, what's still there? It's a k squared. Minus 8k squared divided by 4k. Well, let's think about that. What is it? If I divide out a 4 and a k, what's left is a 2 and a k. So minus 2k. And lastly, if I divide 4k by 4k, that's just a plus 1. There has to be a plus 1. A plus 1 has to be there. If there's nothing there, then when I multiplied, I wouldn't have the trinomial coming back. I would just have a binomial. So check your answer, which you can do. Remember, we've got different ways of looking at it. We can look at what we're dividing, right? That's where these are coming from. Notice the signs are not changing. This was a minus, this was a plus. Okay, so different ways that we can look at this. If that helps, you can do it, or you don't have to have it there. It's entirely up to you. Whatever you're comfortable with, whatever you need to have there. Okay, let's look at example 7, the last one. So example 7, I'll switch to blue here. First thing I'm going to do is I'm going to look at those terms. I don't have a lot of room to go to the left, or to the right, sorry. I don't have much room to go to the right, so I'm going to just write these over here. So my three terms are 15x, that's not a k, that's an x, 15x to the 6th, 24x to the 5th, and 33x to the 4th. So I'm going to look at that 33 and that 15. Do you notice 15 is 3 times 5? Do you notice 33 is 3 times 11? 24 is 3 times 8. Can I get more for my coefficient of my GCF? Can I get more than just a 3? No, I can't, because 5, 8, and 11. 5 and 11 are both prime. There are no common factors there. So 3 is going to be the coefficient of my GCF. And then what power of x do I have to have? I have to have x to the 4th. Remember, it's that smallest power. Okay? It's always that smallest power. So my GCF is 3x to the 4th. So I will take that polynomial. I will factor out a 3x to the 4th. Now, what do I have inside the parentheses? I have to figure out what remains. What would I have to multiply by to get a 15x to the 6th? Well, you can divide if you want to, or you can just think it through. 15 divided by 3 is 5, and x to the 6th divided by x to the 4th. If I take 4 of the 6 x's, that means there are 2 left over. Next, the minus sign will carry through, and we'll do 24x to the 5th divided by 3x to the 4th. 24 divided by 3 is my 8, and then x to the 5th divided by x to the 4th is just x, and we're good to go. Last one, 33 x to the 4th divided by 3x to the 4th. Just divide. 33 divided by 3 is 11, and x to the 4th divided by x to the 4th, the x's are gone. X to the 4th divided by x to the 4th is 1, and we are finished. Can you check your answer by distributing and making sure it comes back to where you started from? Yes. So notice what we have done. We have taken the original polynomial and we have written it as a product. This is multiplication. We've written this as a product. So when we factor something, we're writing it as a product of simpler pieces. In this case, product of simpler polynomials. And that is the end of the video for 5.2.